Hey everyone, welcome to our channel. In this video, I'm going to share you some stuffs which is regarding about ADC. So, first of all, what is ADC? The full form is analog to digital converter, right? So before we are going to be see analog to digital converter, first of all, what is analog and what is digital? So if you are a beginner, this video is definitely going to be helpful to understand about the analog to digital converter. Okay, first of all, analog in a sense, it is going to be continuous in time and amplitude. The data or signal, when it is continuous in time and continuous in amplitude, it is called as an analog. Okay, here I'm just having some example for this. So you just assume the many examples, like if I'm speaking with you, it is one of the analog data because I'm just continuously speaking with you. So all the data you just acquiring, right? So the if it is a measurements, ratio, values, all comes under the analog data. In this example, here I'm just having one adjustable switch. Okay, so in this analog, if you have to see this with the example, it is you can understand this very well because I can able to adjust this brightness of the bulb, right? So when it comes under the analog, you can able to adjust the bulb. So example of this, the temperature, sound, voltage, and from the sensor. So because when the data, you can get the all the data, even it could be the noise, even it could be the junk data, you can acquire the data. This is analog. When it comes to the digital, the question is yes or no. The data is there or not. Like, okay. So here, what is the difference between these two is here using this bulb, I can able to on the switch, off the switch. So through that, I can able to on the bulb, off the bulb. But here I can able to adjust the brightness of the bulb. So that is comes under the analog. Okay. And here's the thing. So it's going to be represented in the form of binary, right? So when you have to come to the digital, you can able to represent in form of binary. And what is the difference between the analog to digital? Okay, so analog means it is going to be continuous in time. Okay, so here I'm just showing you the thing. Okay, so here you just assume one analog data. So this is my data, whatever the data you can assume it. Okay, so you can assume your current value, voltage value, or temperature value, whatever it is, you can get at every instant of time. When the data you can getting every instant of time, even it could be the junk, even it could be the noise. So that is going to be the analog data because at every instant of time, so the time will be continuously you are acquiring the data. When you are going to be come to the digital, it is going to be discrete value. That means so specific values only you can acquire it. So I'm going to tell you that example. Okay, so the best example for this, you can temperature sensor, so the sound which I'm going to speaking with you. So these are analog data, but when you are going to be come to the this kind of microcontroller GPU, that can only acquire the data of binary zeros and one required values. Okay, we can deep dive into the process of analog to digital converter. Okay. First, we studied what is ADC, analog to digital converter, and what is analog and what is digital we have studied. Here, I'm going to teach you and what is the actual purpose, actual things which is happen inside the analog to digital converter. So for that, I'm just having you the three process, which is mandatorily we need to know. So the process is, first of all, the sampling is going to be happen, and second thing, the quantization, and third one is encoding. Okay, if I want to convert my analog to digital data, what are the procedures actually going to be happen? Sampling, quantization, encoding. First, we will study what is sampling. Okay, when you're going to be come to the sampling, your analog data is going to be sampled. Okay, here I'm just speaking through this mic. Example, I just want to show you one example. I'm just go to the sound recorder. Okay, here I am going to start to speak here. Okay, I just on the sound recorder, you can able to see the some data, some pulses. Okay, so these all the data all get sampled. Okay, I'm just speaking through this mic. Okay, that is called as an analog data. That analog data all get sampled, so it just showing like this. Right, so this is what the thing it is. So sampled data means what I'm speaking to you, that data is going to be get sampled at the specific interval of time. Okay, so for example, Yes, if I'm just speaking with through the mic, the wave is keep just all the data is going to be continuously acquiring, right? So how much data, how much sampling I can able to acquire it? If, for example, per second, 44,100 sampling I might get required. So that is called as a sampling rate. And how the sampling going to be actually work? Okay, first of all, your voice. Your voice is your actual analog data. So that actual analog data gets sampled. So how much sample you may get for per second? 44,100 data. So the simple thing is, guys, so you just speak like an your data is actually analog data, right? So this analog data is converted as a sampled one. So sampled in a sense for per second. So per second, how much data is going to be sampled in a sense? 44,100 of samplings you may get. So each is going to be converted as in zeros and ones. Okay, so I'm going to teach you about how it's actually converting. So what are the sampling issue you may get it? So when you're getting the low sampling rate, you might have misses lot of signals. Okay, you might have misses the fast signals. So example, can take the example from here itself. I'm just show you that. So this is my analog data. Okay, this is my exact analog data. If I want to sample my data first, so for per second, so you just take this part. It should sample to the data. The sample rate should be high. So it just sampled a lot of data in specific part. Per second. For this per second, it should be taken around a lot of data should be sampled. Instead, if it is sampled only few data, it might have missed some of the data in between that. Right. Even the sound recorder you can able to see. It should be sampled all the data. So for per second, you should get lot of sampling data. Then only you can acquire the perfect data. Sometimes if you are speaking in the high pitched data, or when you are speaking very fast manner, some of the data might be missed out. So the thing, Nyquist theorem is there. So what is actually the Nyquist theorem is telling us? If you have to see here, your sampling rate is should be 2x to the power of highest frequency in the signal. Okay. If example, the human hearable frequency range is 20 kilohertz, but you need to have the sampling ratio of 40 kilohertz. So if it is a 40 means you should have the sampling rate of 80 kilohertz. Then only you can acquire the data properly. If the human hearable frequency range is 20 kilohertz means you should have the sampling range of 40 kilohertz. Then only you can acquire the all kind of data, high pitch data you can acquire it. And if I'm speaking very fast manner, that data is also you can be able to acquire it. So that's what the Nyquist theorem is telling. So it should be high. Okay, your sampling rate should be high comparatively those normal signal. Okay, and what is the real life applications of this one is, so yes, the audio you have getting, so audio recording. So while I'm going to do the audio recording, how much sampling rate is actually it is 44 point kilohertz. So 44 means 44,000 hertz. So then only it is the highest sampling rates. You just consider as in per second. So you may get a lot of sampled data. So you will get the accuracy is high. So not only recording audio, it is useful for in the videos also. So videos, if you have to come to this, so number of frame per second should be high, right? So the number of frame per seconds should be high. Then only you can acquire the data without any lagging like that, right? So here's the thing is when you have to use the whole phones, which is like a Nokia, Samsung, so the whole model phone, button phones, so you can feel that some too much of lagging in that phone, right? Because the frame per second is less in that. So when you are having the lot of samples, so that is also one of the sampled, right? So the data, analog data, you just sample the data and bringing out. So your frame per second should be high. So that is considered as an analog. So when you have to take in for the sensor, it is also for the good example for the sampling rate. Your sampled data should be high. So I'm going to explain about this clearly. What is sampling data? I'm just speaking. So Arduino can sample around 10,000 per second. So for per second, you can acquire the 10,000 sample data. So what is the summary of this one is? So sampling in a sense, it's just capturing the analog signal. So simply just assume it. First of all, we have studied what is analog and what is digital. Right. So analog in a sense, you're just capturing the data. What actually I'm speaking with you. And what actually you're just capturing. So just capture the analog data and you just converted it into the sample. You just sampled the data. You just split it out and you got some sample data for per second around 44,000 sample data. And you the second important thing is you should have the higher sampling rate. So then only you can acquire the more accuracy data. If you are having the less or lower sampling rate, you might have feel some that loss of data. You can feel you will lose so much of data. Okay, and what is second thing is quantization. So what is actually the quantization it is? Because again procedure quantization is going to be happen, right? So quantization in a sense is just rounding off the data. Okay, so before we are going to converting the analog signal into the digital signal. So what is actually happen is first of all sampling the data, it just quantizing the data. So what is rounding off? We are going to be see that here you can able to see this one. I'm just show with an example. So you are having the one data, okay? This is my exact analog data and this is my time, and here you just taken an amplitude or voltage or current, so whatever it is, okay, or temperature. So the data you just trying to acquire it. If I'm using thermometer, I'm just getting the temperature data. If I'm just taking the measuring the current value, I'm just acquiring the lot of current data. So that data I'm going to sample the data and do for the quantization. So I'm going to teach you about what is quantization now. So in this case, what is quantization if you have to see this? So this maximum voltage or maximum range you just having that. Here I'm just choosing the voltage value. Okay, so this maximum voltage is 5. But rounding off in a sense, you will the first procedure is completed, right? You just sampled the data. The data you got it. You just sampled the data. Here you can able to check with this one. You just sample the data like this. And after, definitely you will have some value here, right? So for this specific time, you will get some voltage value, right? 0 0.4 and 1.23 or 2.5, so 3.3, like that value you can get for the sampled data. So that data, it is going to quantizing, that means rounding off the data. If I'm just acquiring the data of 0.4, it just fixed that value to 0.5. So rounding of the data. Okay. So if I'm just acquiring the value of 1.23 in a sense, it's just rounding off the value of 1.25. Okay. If I'm just getting the value of 4.9 in a sense, in just rounding off the value of 5. So likewise, what is the purpose of this? Just rounding of the data. Okay. So it just fixed value is going to be get it. And quantization is going to be the main purpose is going to be rounding off. Here, I've just mentioned for the temperatures. If using thermometer, you can read the temperature value. If I'm just getting the value of 27.3 degrees Celsius, is either just rounding off the value to 27.0 or 27.7 degrees Celsius. So that is the purpose of quantization and how it's actually working. Here, I've just mentioned one bit resolution. So, what is bit resolution? If you see this one, each microcontroller. So you have to check this one. You might have used microcontroller or whatever the device you are using. It is having the default bits. That means ADC bit. Here I'm going to select my microcontroller. So there is a lot of microcontrollers there. So Arduino, STM32, or likewise ESP32. Likewise, many microcontroller is there. But here, what is the bit of ADC bit which is present in the Arduino is 10 bit, and STM32 is which is around 12 bit. ESP32, you just check it on this. So if it is a 10 bit means you can acquire the data which is around 2 to the power of 10. That means you will get 1024, right? So if it is 12 in a sense, 12. So 2 to the power of 12. So you will get some 4094 like that values. So these are the resolution values. Okay, so where it actually working if you ask, the data you are going to be getting, right? So depends on the resolution value, that much amount of data you will get. For example, we have taken one example. I'm just having one soil moisture sensor. Okay. So you just take it for the 8-bit also. It is very good to differentiate that. 8 bits you will get for the 256. Okay. The first thing is I just bring one soil moisture sensor. So that soil moisture sensor, what is the purpose of that? So the name itself, which is having. So it just measure the moisture level which is inside the soil. Right. So if I'm just using the ADC, through that ADC, I'm just acquiring the data. Okay. I'm just having one logic. Uh, First of all, I'm just taking the 8-bit ADC. Okay. I'm just taking the 8-bit ADC. So the values you will get for 256. Okay, even though it is having a lot of value, you will get, we just shrunk the values to 0 to 255. So if you have to taken for the from 0, you will shrunk the value 0 to 255. So the data which I'm getting, first of all, I'm just write the logic. First condition is condition 1. If I'm getting the value from 0 to 100, it is the moisture level is very low. Okay, this is my first logic. And the second logic I'm just writing. So if the logic is 100 to 200, it is slightly having the soil. I mean moisture level is there, which is around 50 to 70% moisture level is there. If third condition is you are writing like 200 to 255 exact value. If it is the value which is comes like that, it is a lot of moisture level which is in the which is in your soil. Okay. So the condition which you have written, okay, fine. But while you're using the less amount of bits, less amount of resolution, you can acquire only the 100 data. You can check whether your soil is dried. So you can check only with the amount of 100 data, your moisture level of your soil is slightly having some moisture level. And if you have to check with your data, I mean soil moisture sensor, it is having too much of moisture level, you can get only the 55 data only. But just think about this 12-bit ADC. So you have to come to this 12-bit ADC, you will acquire the 4096. Okay, so from 0 to, you have to consider this, you will get the 4095 data. Okay, from here, if your soil is having there is no moisture level, you can get the thousands of sample data, you will get it. So just to compare this one, so how much accuracy will get it? Okay, here you can only predict your soil with the help of 100 data. But here you can able to predict the data with the help of the thousands data. Okay, the same thing, condition 2, I just want to tell you that. Here you can predict the data same like 2000, or you can change your data like 3000 also. So your soil moisture sensor, I mean soil which is having the 50 to 70 percentage of moisture level. So you can acquire the data which is around what amount of data you can acquire the data which is around 2000 data. So 2000 using the 2000s data, you can able to predict your moisture level of soil. Okay, so with the help of that 2000 data, so you can predict your soil whether it is having 50% or 30%. Okay, third condition is 3000 to 4096, exact value of 4096. If it is having that value, 3000 to 4096, it is having the enormous moisture level in your soil. So just to compare these two things, guys. From here, you can clearly understand about this, what is resolution and what is fill. So depends on your ADC, which is developed by the specific company. So it's their own wish. Arduino as developed by 10-bit ADC. STM32 developed by 12-bit ADC. Right. So while you're going to be choose instead of less bit resolution, you will get only less predictable values, sampled values, but you are going to be come to the high resolution values. You can get the lot of data. It is going to be helpful to analyze your data very well precisely. So I hope you guys you got this point clearly. Okay. And next one is, so here I'm just bring you an example. Okay, this is all the stuff which you have currently studied that. So when you're having the very so what is the problem you can able to face this one using this quantization? I just told you this one. So previously I discussed about what is this. Okay, so here while doing this quantization, so purpose of quantization is going to be rounding of the value, which I already told you that. So if you are getting the 1.24 means it just convert the value to rounding of the value of 1.25. So this is the exact purpose of this one. So what is the issues you may get feel it? While doing that, you may loss of information and loss of data. Okay. So the thing is, this is my data. This is my analog signal. Just consider this is my analog signal. So this is my voltage or current or whatever the value it is. So the value which I've got, the sampled value is 1.24. Okay. But it just convert rounding off the value to 1.24 to 1.25. Here my value was get jumped. So instead of this value, you can acquire this value, right? This time you can feel some of the mini data you can able to lost it on here. Okay. You can feel uh you can lose the data from here. Okay, this is the first thing you can lose it on here. And second thing, instead of taking the good data, you may acquire some noise data. Okay, while doing this rounding of the data. So because already the data get sampled, while doing this rounding of the data, instead of it just missed out it just instead of taking the good data, it might taken the some noise data, and you may missed out a lot of small tiny data. So that is the issues. What is the solution for this one is, if you are going with this high bit resolution bits, if you are go to the 12 bit or 16 bit, these problems will be avoided. Okay, while doing the sampling, most of the noise is going to be gone. So because you can acquire the lot of data, so the problem is less. So you cannot miss out the data like this. Okay. So the next one is the summary which we have studied. So what's quantization? It's just rounding of the data, rounding of the values. And if you are taking the more bits, the more precision will be you will get. So error exists but can reduce the high as a resolution going to be reduced that. So even though you have to get some error values, but while you are going to be taken the high resolution bits, so this kind of errors or noise going to be avoidable. And next thing is encoding. So encoding is another important stuff which you're going to be studying right now. And first, what is encoding? If you have to come to this, encoding in a sense, you just simply thinks how you have studied from the starting, like what is sampling. So sampling in a sense, your analog data is going to be converted to sampled data. So for per second, how much data is going to be splitted like sampled. Okay. And so that sampled data is going to be, what is going to be happen? It is going to be rounding of the data. So the sample data will be rounding off here. So this is what the encoder it is. It just converting the final procedure of this step. So sampling, quantization, and encoder. So through this encoder, the exact value is quantized value is going to be converted as in some binary value. Here I'm going to teach you that. So first of all, you just taken one example of 1.2 voltage. So that means this is your maximum voltage value and this is your time. Here, this is your analog data. Okay. Yeah, you just sample that data. So one of the sampled data is going to be 1.25 like that, some value. And that data is going to be sample and just all the data. And this quantizer is going to be match the closest voltage value. So I already told this. And this encoder is going to do the convert as an exact. So convert as an exact binary values. Okay. So here you can able to see this one. I'm going to teach you this what is actually is telling. So before that, guys, if you want to find the each voltage value, so if it is want to sample the values, how much minimum voltage it might have required. Okay. So you have to check it on that also. So this is my data, analog data. Okay, this analog data is going to get sampled, right? This gets sampled, and this is the maximum voltage of 5 voltage, and this is my time. Okay, so if you want to find what is the exact each data is going to get sampled, if you want to find that thing, so for that, so one technique is there. So what is you are going to be do is the device you have chosen, the microcontroller device you have chosen, how much bit it is. So if you are having the 12 bit, you can get the resolution value of 4096, right? So you have to divide that value by this one. So what is your maximum voltage divided by what is your resolution value? When you are going to do this technique, you can find the each minimum voltage is going to be get for each data is going to be get sampled. Okay, so that's the first thing. Here that is not one. Here, if you want to get the level of your binary values, because you have to sample the data, right? And you need to know what is the level of each values. Here you can able to see the voltage value. If you want to know the what is the level of this value, you have to do the here divide by what is the exact voltage value. See, you can have the one voltage value here. So what is the exact voltage value, which is divided by your what is the each data is going to be get sampled. So that voltage you are going to be divided here. So that minimum voltage is 0.0195. So when you're going to be divide that value, you can get the some level of your digital value. So I'm just simply telling you guys. The two things is the first thing, if this is my analog data, okay. I just want to convert this analog data going to be get sample. So the sample data, each data, how much voltage is going to be taken, the minimum voltage, how much if you want to find that. First of all, you have to check with your microcontroller device, how much bit device, how much bit ADC it is. If it is having the 8-bit ADC, it is having 256. Okay. So then what you're going to be do is what is the maximum voltage of your voltage you have given to for this ADC. So that you have to take in maximum voltage divided by resolution. If you have taken the 10 volt, so it just divided by certain value. So if you have taken instead of 8 bit, if you have chosen the 10 bit, you have to divide the value by 1026 or 5. Okay. So that's how you have to do this to find the minimum voltage value. Okay. And instead, if you want to find the exact digital value, what is the level of your value, what you're going to be do is, so this is my analog data, right? So each value, how much voltage you have taken, you have to already find that. That is around 0.0019. Example, you have to take in. So you have to take the what is the level of your voltage value. So you have sampled the level of your voltage value. You have to take an example 4.1. Okay, 4.19 example. And another minimum voltage is 0.0019 voltage. So when you're going to be divide this value, you can acquire the data. What is your level of this value? Okay. So the data you have got this one, right? The 23, example 23 or 45, any data you. So that digital data you have to convert as a binary now. That's the simple. So it has convert the analog to digital data. Example 23 is my data. You just do the decimal to the digital value into the binary value. So you have to do this calculations like, yeah. So by 2, you will get 5, 1. So 2, 2, or 1. So 2, 1, 0. Okay. So what is the value I've got it? 1, 0, 1, 1, 1. So these values only given to your microcontroller or laptop because these stuffs wouldn't understand the human understandable language. So these are the staffs who didn't understand the human understandable language, right? So that's what we are doing here, converting your normal digital values into the binary values. So only these kind of data. So for 23, we have found this value. For 45, you have get the 1100 like this value, you have got this. So these are the values only given to a specific microcontroller. So that's how this procedure is actually going to be happen, guys. It is really amazing. If you are liking this video, just post it on the chat box or comment. Really awesome. Okay. So example bits I have mentioned here. So this is what the levels, guys. I already told how the levels is working. So if it is 8 levels and it just specifically chosen the closest level of sixth when and it just convert as a value of binary value. Okay. And ADC knows the voltage range but can't express in binary. Yes. So it just helps to with the encoder, we just express in form of binary. So that only we are going to be imported into the microcontroller or any devices. Okay. So it has chosen the nearest value and it just converts the binary value. So this is the flow, the sampling. So the analog data, what we are getting. So that analog data, we just converted as in sampled data. So captured some sampled voltage values or current, whatever it is. And it just do the taken the closest nearest value and it just do the encoding. So what are the key parameters which is important is this is what already we have discussed that. So that resolution, yes, because the which ADC you are actually using, 8-bit ADC or 10-bit ADC or 12-bit ADC. So if you are using a high bit ADC like 12 or 16-bit, you can get the high precision values. Okay, this is also I have discussed that. So this is the levels. So if you are choosing the 8-bit ADC, 2 to the power of 256. So that much values you can acquire it, right? So example for the step voltage value. So this is also I have teach you already, guys, how you are going to be find the per step voltage value. So the maximum voltage divided by your actual resolution value, you can get the step voltage. How much voltage it can actually require for the each sample data. If you are using the 5 voltage value and resolution value of 1024, so 12-bit ADC, this is how the exact value. And if you are using the 5 voltage and the bit is which is around 12-bit ADC, this is your step voltage. And likewise, you are going to be calculated. Okay. So this is how the flow it's going to be, guys. So this is what I've already explained you. And here, so example thing I've just given here, if you are getting the value of 409, so you just convert the values into the actual binary values. Yes. So I'm just give you some overview what we have discussed in this class. First of all, I just teach you about what is analog to digital converter. What is analog? It is continuous in time. So you can acquiring the data at every instant of time. You can acquiring the data, right? And how this analog to digital converter actually works. So three techniques actually happens: sampling, quantization, encoding. Sampling, you just sampled your data, actual analog data to sample that data, and the sample data is just holding on that sampling. And the quantization, you just rounding of your actual voltage value. So third thing, so the data which you have gotten, that data, that level of value is going to be get converted as in binary values. So that's the flow for your complete analog to digital converter. Here I just teach you the uh, how much voltage value, step value, and so how to find the level. So everything I've teach you on this session. So I hope you this video is definitely going to help you to find and help you to understand the what is ADC and what is actually happens in that inside this ADC. So I hope you this video really help you to understand what is ADC. If you really like this video, hit the like button, and if you feel this video is definitely giving some knowledge to understand how to ADC working, so just write the commands for with some few words. Okay. So see you on the next video. So until it's goodbye from Charlotte. Bye, guys.